Continuation of the black set for the greatest common factor in distributive property 2. Problem number 6, 100x plus 35. Greatest common factor of both of these numbers. 35 is not a factor of 100. So I can come over and see what my factors are for 35. 7 times 5 gives me 35. These are both prime numbers, so that is my set of factors for my prime factorization. 7 is not a factor of 100 because numbers that end in 0 have to have factors that either end in a 5 or a 0. So my greatest common factor must be 5. So I'm going to use 5 here, set it outside the parentheses. 5 times what gives me 100x? That's going to be 20x. And 5 times what gives me 35? That's going to be 7. Check myself. That does give me 100x, and this does give me 35. Number 7. $42 plus 14. Ask myself, is 14 the greatest common factor of 42? Again, if I don't know, I can use my calculator to help me out. I know what 14 times 2 is. That's 28, so I'm going to check 3. It is. 14 is a factor of 42. So my greatest common factor here is 14. This is a good example of one where somebody might think the greatest common factor is 7. But the greatest common, 7 is a factor of both of these, but it's not the greatest common factor. And we want to find the greatest common factor. So 14 times what gave me 42? Well, that was 3, so 14 times 3a will give me 42a, because when I multiply these using the distributive property, I will get 42a. And then 14 times what gives me 14? That's 1. And I will get 14 when I multiply. Number 8. 66x plus 48. Well, I know that 48 is not a factor of 66. 48 times 2 would be much larger than 66. So let's see what my greatest common factor, or excuse me, let's see what the factors of 48 are. I can choose any 2 factors that I want. I'm going to choose 2 times 24 because when this is even, I know I can always use 2. There's 12. So those are my factors of 48. 2 times 2 times 2 times 2 times 3. So now I can check 66 if I'm uncertain of those factors. Whenever you have a 2-digit number that repeats the same digit in both the ones and the tens place, we know that 11 is a factor. So I'm going to use 11 times 6 is 66, and 2 times 3 is 6. So my factors here are 2 times 3 times 11. And when I compare these, I can see that I have a 2 times 3 here, and I have a 2 times 3 there. So my greatest common factor for these is 6. So 6 times the quantity, this is going to be 11x, because 6 times 11x gives me 66x, and 6 times what gives me 48? That is 8. Number 9, 64n plus 24. So let's check 24 and see if it's a factor of 64. I know that 24 times 2 is 48, so I'm going to check 24 times 3. Nope, too big. So I can't use 24. So let's check and see what the factors of 24 are. 2 times 12, 2 times 6, and 2 times 3. So my factors of 24 prime factorization is 2 times 2 times 2 times 3. And I could factor out 64, but I could also just look at these and say, well, 2 times 2 is 4. Is 4 a factor of 64? And again, I can use my calculator. Well, it is. Let's see if it's the greatest one, though. Another factor of 24 would be 2 times 2 times 2, which is 8. Well, I know that 8 is a factor of 64 because 8 times 8 is 64. And I know that 24 is not a factor, 2 times 2 times 2 times 3. So let's see what 2 times 2 times 3 would give me. 4 times 3 is 12. Let's see if 12 is a factor of 64. Nope. And then I have 2 times 3, which is 6. And if I look at 64 divided by 6, nope, that doesn't work either. So it looks like the greatest common factor I have here is 8. So greatest common factor is going to be 8. So I'm going to put 8 out here. 8 times 8n would give me 64. 8 times what gives me 24? That is 3. So you can see when I do my factoring, or excuse me, my distributing, I do get 64n and I do get 24. I also know that I chose the correct greatest common factor because there is not a common factor between 3 and 8. So that ensures that I did indeed choose the greatest common one over here. Number 10, 35k plus 84. Well, my smaller number is 35. It ends in a 5. This does not end in a 5 or a 0, so I know this is not one of my greatest common factors. So I need to factor out my smaller number. And I can see that I either need to have 7 or 5 as a factor of 84. So I'll just go ahead and do the prime factorization on this. Let's see, 42 times 2 gives me 84. So there's a prime number. I know that 6 times 7 is 42. There's a prime number. I know that 2 times 3 is 6. So 84 is 2 times 2 times 3 times 7. So it looks like the common number I have here is 7 between the two. So I'm going to factor out 7. Seven times what gives me 35K? That would be 5K. And 7 times what gives me 84? And if I'm not sure of that, let's take 84 divided by 7, 12. So when I look, 5 and 12 do not have any common factors, so I can be confident that I do have the greatest common factor out here. And when I distribute, if I were to distribute that 7 throughout the equation, this would be 35K and this would be 84.